So students, discussion chal rahi hai about the digital to digital conversion. We are talking about line coding to be specific. And before we go into the discussion of line coding, we are talking about some basic concepts. We already looked into the data elements versus the signal elements. What we're going to talk about right now is the concept of data rate versus the signal rate. Students, the data rate is the number of data elements that we can transmit in 1 second. The number of bits that we can transmit in 1 second. Students, signal elements or the signal rate is the number of signal elements that we can transmit in 1 second. Students, data rate is also called as the bit rate. And therefore, it's measured, the unit is bits per second. The signal rate, it's also called as the pulse rate, the modulation rate, or the baud rate. And the unit for signal rate is bauds per second. Students, the inherent property in a data communication system is our intention, our ultimate intention is to increase the data rate and decrease the number of signal elements that are required to actually carry that amount of data. What we want to do, if you use the analogy of some people traveling in a car, what we want to do is we want to take as many passengers as possible in one single car. Increase in data rate means that we are increasing the transmission speed, an ultimate goal in any data communication system. Decrease in signal rate means we are decreasing the bandwidth requirement of that data communication system. Students, both of these factors, the increase in the transmission speed with an increase in the bit rate or the data rate, and the decrease in the requirement of the bandwidth with a decrease in the required signal rate, both of these define the efficiency of our data communication system. Students, slide pe chalenge and we'll have a look at how this data rate is related to the signal rate. Students, if we represent our signal rate with capital S, and our data rate is represented by capital D, and we have already gone through R in the previous discussions, and we know that R, the ratio R, is nothing but the number of data elements carried by each signal. Number of data elements carried by each signal element. Now, S, which is our signal rate, is equal to D, which is our data rate, divided by this ratio R. Now, students, let's look at an example in which we have got a signal which has got a signal rate of 100 bauds. We know that the ratio R is 1 because it's given that only one data element is carried per signal element, and we need to find the data rate. We know that our signal element or our signal rate is equal to the data rate divided by the ratio R. Our data rate is going to be our signal rate multiplied by the ratio R, and in this case it is 100 multiplied by the ratio which is 1, which gives us the data rate for this particular transmission medium to be 100 bits per second.